Okay. Okay, today, or this is a basic video about um, of voltage dividers, maybe a little introduction about Kirchhoff's volt law, or better known as KVL. So here we have, this is basic for any circuit analysis. If you are going to be a entry-level circuit technician, or if you're going to be an engineer, this is stuff you need to know. So we have a 12-volt source. Forgive the horrible drawing. 12 volts. Let's just say it's 12 volts. This is DC, so it's a constant 12 volts. And we'll say it's an ideal power source, meaning it's always going to put out 12 volts no matter what. Such a thing doesn't actually exist, but for this example, we're going to say it does exist. So we have a 12-volt supply, and then we have a basic resistor network here so we have a resistor network. We have one resistor, two resistors, and three resistors. And then we always return back to ground. Always. The circuit will not work if it doesn't return to ground. So for the sake of this, we'll call this resistor R1, and later we'll fill in actual values. But for right now, we'll call this R1, this resistor R2, this resistor R3. So if I wanted to know the total resistance of this circuit, it would be R1 plus R2 plus R3 equals R total. So if you were to take a multimeter and there was no voltage, do not use a multimeter and check resistance with voltage applied. It's a quick way to wreck your multimeter. So if there were no voltage here, and you stuck a probe right here, and you stuck a probe right here, your total resistance would be R1. The resistance that would show on your multimeter would be R1, R2, R1 plus R2 plus R3. Given that this is an open circuit here, there is no other connection. So now we covered some really basic introduction that you probably should have already known. We get to the voltage divider part. So now this voltage supply is back in circuit. It is back in the circuit with R1, R2, and R3. So this voltage supply will, again, it's ideal. It will always supply 12 volts to this point right here. So if you take your multimeter, stick the positive probe here, the red probe here, stick the black or negative probe here, you will read 12 volts, a 12-volt potential, no matter what, because this is an ideal supply. So we know that's 12 volts here, but what is our value at this location? Well, the value at this location is easily found. It is going to be from our R total that we found earlier here. It's going to be the R total divided by, or I should say, the R total is the dividend, and whatever is in series in this circuit is, or whatever remains in this circuit is going to be your divisor, or your, so we have R2 and R3 remain in the circuit at this point right here, R2 and R3. So it will be the R2 plus R3 divided by R total times 12. So times 12 volts. So now we'll use some actual values here. Let's make it them nice and easy values, but you'll see that you can put any value you want in here and it will end up being correct. So let's nice easy values of 4 ohms, 4 ohms, and 4 ohms. So R2 equals 4, R3 equals 4, divided by the R total, which is 12, gives us 8 over 12, which simplifies to 2 over 3, and we multiply that by 12 to get 24 over 3, or better known as 8 volts. So if you stuck the red or positive probe at this point right here where my arrow's pointing, and then the other point here at ground, the potential would be 8 volts. This will be true no matter what value. This formula right here will be true no matter what value of R1, R2, and R3 you put in here. And we can see it also follows Ohm's law here, or V equals IR. So we know our voltage is 12. At this point, we know our voltage is 12. We know our current. We don't know our current right now. We do know our resistance is 12, and we don't know our current. We divide both sides by 12, so we know our I, or our current, equals 1 amp. So we know, and from KCL, Kirchhoff's current law, we know that current at any point in this circuit is always the same. So if we have 1 amp here, or I just drew this arrow, we also have 1 amp here. Current in equals current out. It has to go somewhere. So we know that everywhere is 1 amp. So again, showing you that Ohm's law is still maintained here. V equals IR. Our resistance total from this point to ground is 8. So we know our R is 8. And we know our I right now is equal to 1. So 8 times 1, really ugly, equals 8 volts.